More and more children are out of school, but parents don't want math learning to stop. They're turning to Mathnasium at Home. Real-time math instruction tailored to your child's exact educational needs. It's the same face-to-face live instruction used in our centers for over 15 years, now on a computer. Your child can keep their math skills sharp, catch up, or soar ahead, from home or anywhere with an internet connection. To learn if Mathnasium at Home is right for your child, visit mathnasium.com/at-home. Mathnasium at Home, changing lives through math.
Hello everyone, welcome to the Mathnasium Schoolhouse. I am John, the AVP of Education and Training for Mathnasium. And as always, I am really excited that you joined me today. It's Friday, right? And I hope you all are enjoying and thinking about your weekend ahead. And you could all be somewhere else right now, but you're here with me, and that means a lot to me. And thanks for joining me. So if you've been with me before for any of the other mental math sessions that we've done, certainly welcome back. If you're new, that's awesome. Thank you so much for joining me. I want to talk about, the title of today's lesson is Knowing Left from Right, and I'll get into what that means in a moment. If you've joined me before, we spent a lot of time talking about when you're doing mental math, the importance of working actually from left to right, which is opposite from what you learn in school. And when you learn how to add and subtract, generally you work from right to left. So I wanted to focus today on our 4 operations and certainly strategies to get you to think about those problems mentally, working from left to right, which is really cool. As always, we've provided a follow-along worksheet, so you can use that. I will do more problems than that, certainly. You can take notes, and I hope you watch these videos and all the videos that we've done. I think at this point we've probably done about 75 of them, which is interesting. And you can watch it again. All these things, they certainly take practice, so don't let it be frustrating. You can write down whatever you want. I'm going to, as always, write things down. And a lot of what I write down is what you should be doing in your brain. And the whole point of doing this is to prove to you how smart you really are and how your brain is the most powerful thing, and keeping in mind that it also takes practice. And it's important to know that it may be hard at first, but with practice, you will get it and you will be awesome at mental math. And being good at these things will cause all of your other math to be better, and you'll find interesting ways to apply to things that we've talked about. So what are we going to work on today? We're going to work on addition, subtraction, multiplication, and division. But like I said, everything is going to be focused on working from left to right. Okay, and then I have a little wrinkle that I'll throw in at the end. So diving in, I mentioned the 4 basic operations: addition, subtraction, multiplication, and division. And 3 of those 4, you generally work from right to left. Addition, subtraction, and multiplication being the 3 that you generally work from right to left. And then division is the weird one where you actually work from left to right. And sometimes math gets confusing because just when you get the hang of what's going on, then all of a sudden division comes in and you're working on long division and you're working from left to right, which is the opposite of what you normally do. And it's important in school to be able to work from right to left. So I don't want you to necessarily stop doing what your teachers ask you to do. It's important to be able to do things that way. But one of the goals of being a really great math student is to be able to look at a problem and find a bunch of different ways to solve it. We talk about that a lot. And that includes looking at things that kind of a basic addition problems and being able to solve it in multiple ways. And that causes you to be a much better problem solver later. And that's the reason why we do these things and why we do these things at Mathnasium. So if you're a Mathnasium student, you probably practice these things a lot. So with all of that said, let's start with addition. And when you start these problems, I want you to think about Well, I definitely want you to keep working from left to right in mind. And think about whether these problems require you to carry at all, okay, or whether they can be done without carrying or without borrowing. So if you're looking at a problem such as this, you definitely can start on the right, and you think, okay, 0 plus 0 is 0, and then you work your way over to the 8 plus 6. But I want you to shift your focus on these and think left to right. Okay. So this one is kind of a good warm-up. 80 plus 60, hopefully you got 140. And that's not too bad. You could think of this as being 8 tens plus 6 tens, which is 14 tens, which is 140. And a lot of what we're going to talk about today with working from left to right helps you become much better with your place value. So more than just addition and subtraction and multiplication and division. If you practice these things, it helps you with your place value. Okay? And then it becomes more than just numbers. And at Mathnasium, we spend a lot of time talking about what's called quantity and denomination. Okay? And quantity and denomination mean that we have a certain number and a certain name. Okay, and that very much applies to place value. I have 14 tens, which is the same as 140. Okay. And that's another way to think of it. All right, let's make it a little bit more difficult, because I know you joined me today for the challenge. Okay. And I want you to do these, and remember, I want you to try to do these mentally and see if you can get that answer mentally. But try to go this way. Hopefully you got 185. Okay. If I'm working from left to right, I have 100. I'm adding 0 hundreds. So my answer has 100 in it. I have 1 10 plus 7 tens is 8 tens, and I have 5 ones plus 0 ones is 5 ones. And that addition problem, I hope when you looked at it, the first thing you thought was, that's an addition problem where I don't have to carry. Because you don't. And in addition problems where you don't have to carry are, with practice, very easy for you to go from left to right. Okay. Even if you went from right to left, it's not so bad. 5 plus 0, 1 plus 7, and 1 plus nothing. No carrying. Okay. All right, let's do one more. And again, I want you thinking first thing, I want you to think, do I have to carry at all? And if you're not sure, how do you know? Or let's talk about how you would know whether you need to carry or not. Look at each of these. Change my color here. Let's look at each of these individually. Are any of those larger than 10? Or 10 or more? Sorry. If the answer is no, I don't have to carry. I only have to carry if I end up with 10 or more of whatever 10 ones, 10 tens, 10 hundreds, whatever it may be. So again, we're thinking work from left to right. It helps with mental math. You get 378. 2 plus 1 is 3. 3 plus 4 is 7. 1 plus 7 is 8. I work from left to right. And I have my answer. Okay? So now the question is, what if I have to carry? And let's talk about what some mental math strategies look like when you have to carry. And like we just talked about, when you look at that problem, you think I have to carry, and it's because when I add 7 and 8, I get something that's 10 or more. Okay. But carrying in the way that you learn how to carry when you're doing it the way you learn it in school, which you need to be able to do that too, and that's okay. But that becomes hard to keep. That becomes difficult to keep track of in your head, especially as the numbers get bigger. And a lot of these strategies that we learn that are mental math strategies that you practice allow for you to keep simpler things in your head. If I had 3 or 4 digit numbers here, then I have to keep all that carrying in my head and when I carry from one to the next. So the way I want you to look at this is, and I'm going to stretch your brain just a little bit here because this is going to be a little bit different, but not too far off from what you normally would do. I want you to think of this, and remember we're working from left to right. I want you to think about 5 plus 2 is 7. And I want you to think about 7 plus 8, which is 15. Okay. And remember, see now when I look at those two numbers and I think, okay, 7 and 15, that's going to be a little bit easier for me to keep track of in my head. But remember, this really helps you with your place value. Okay? If you practice this, it's really good for place value. So remember, this is not 7, it's actually 7 tens. Okay? So when you think, okay, 7 tens. And I have 15 ones here. But in order for me to finish this, I take this 10 and I add it to the 7 and I get 85. Okay. So when I'm doing this mentally, I think 7 and 15, and then I carry the 1 over and I get 85. Now, is that any different than writing the 1 up here? No. But in your head, it's helpful to keep track of 7 and 15. You can put those two things together. And if you practice that, you'll see it's very simple to put these numbers together as you add them. Let's do another one. So let's say 46 and 35. And I have a few more to do after this, so let's do this one quickly together again. So I want to add 4 and 3, which is 7. And I want to add 6 and 5, which is 11. I can hold 7 and 11 in my head, and all I have to do is carry this 1 over to my 7, and I get 81. Okay. So I'm working from left to right, and I'm taking those two sums and I'm putting them together. I'm linking them together. And it's because this is 7 tens, this is 1 10, and my answer has 8 tens in it. So remember, try to think of this, do this in your head. And what I'm writing down here is what I'm trying to get you to do in your brain. Okay? Let's do another. So 95 plus 32. This one's a little bit different. And remember, we're going to try to go from left to right. We're going to go this way, which probably doesn't help if I'm doing it on my screen. I want you to go this way because we're trying to do it mentally. So I'm going to start with the left. I'm going to start with the 9 and the 3. What's 9 plus 3? I get 12. On the right, I get 5 plus 2, which is 7. There's nothing for me to carry, and my answer is 127. So on that one, we just take those two things and we put them together because there's nothing to carry over. Let's do one more. So let's say 76 plus 45, and I'll give you a minute to try this one. Maybe not a minute, but... So this one is interesting. If we add 7 and 4, we get 11, which remember is 11 tens. Just be very, very careful when you're thinking. Everything has a name. This is 11 tens. It's the same as 110. And I have 6 plus 5, which is also 11. This one's a little bit different than any of that we've done before. But if you remember place value, Remember, this 1 is 110. I add it to my other 10s and I get 121. So when you see things like 76 and 45, you can think 11 and 11 and carry that 1 over and I get 121. And if you practice this, it becomes much easier to do. And when we do other mental math lessons together, we'll make these numbers bigger and we'll keep practicing these things. But if I had 3-digit numbers, then I can keep 3 things in my head and then carry them over and put them together. Okay? Which is going to be a lot easier than trying to remember all this carrying that we do pencil to paper. All right. Let's talk about multiplication, and we'll talk about subtraction next, after multiplication. So let's talk about something like 46 times 2. Now, if you've been with me before, we spent a lot of time talking about multiplying things by 2, by 4, by 8, by 16, even by 32, and that's because it's all related to doubling. Multiplying something by 2 is the same as doubling it. So if you're really good with your doubles, then you already know what the answer is. And even if you need to do it with carrying, 2 times 6, carry the 1, that's okay too. Maybe you're just getting used to multiplication, or maybe you're just learning it. But if you know your doubles, then actually you know more than you think. You know your times 2s, your times 4s, times 8s, times 16s, 32, 64, as far as you want to go, as long as you can keep doubling the numbers that you have. But I want to talk about this with you in the same way we just did addition. That's why I skipped to multiplication. Okay. I want to work from left to right. I want to multiply 4 times 2. And I get 8, and I want to multiply 6 times 2, or 2 times 6, and I get 12. And that's why I wanted to show this to you, because if you get good with this technique, it actually works for multiplication too, which is really cool. So now all I have to do, remember this means 8 tens, means 80. I bring over my 1, and I get 92. Okay. So now you can practice your addition and your multiplication. And you have a really cool technique to try to do it mentally. Okay. Okay. Let's do another one just like that. Let's do 34 times 3. I'll give you a minute. So remember, working from left to right, 3 times 3 is 9. 3 times 4 is 12. Put these together, you get 102. Okay? And just remember what these things mean. That means 9 tens. That's 1 more 10. My final answer has 10 tens in it, and I have my 2 ones. In a previous mental math session that we did, we thought of 34 times 3 as being 30 times 3, plus 4 times 3, which is exactly the same thing that we're doing here, except we're not thinking of this as being 90, we're thinking of it as being 9 tens. And that's why I keep saying it helps to think about it in terms of place value. Because when the numbers get big and when we apply these mental math strategies to bigger numbers, not thinking about all these zeros actually really helps a lot. If we start having numbers that have hundreds and thousands and 10,000s in them, then all these extra zeros kind of get in the way of what we need to keep track of in our brain. And we're not cheating, and it's a trick, but we're not cheating. This 9 means 9 tens, and that's okay, as long as we keep that in mind. Okay, let's try a couple more. So let's say 52 times 4. Let's try to do it mentally and going from left to right. And like I said, if you want to double and double again, you certainly can, because that's the same as multiplying times 4. But that's the beauty of math, is that there's always a lot of ways to look at this. Look at things. So let's start with 5 times 4. You get 20. 4 times 2 is 8. There's nothing for me to carry here. It's just 8. It's not 10 or more. So my final answer is just 208. Like I said, if you started with 52 and you double it, you get 104. You double it again, you get 208. Either way. Awesome. Let's do one more multiplication. Let's do 63 times 5. So 6 times 5 is 30. 5 times 3 is 15. So you think 30 and 15. Now you just have to figure out how you put these two numbers together. $315. So I have 30 and 15, and I want to take those two numbers and put them together. Remember, this is 30 tens, which is 300. I have 30 tens. I need to add one more 10. That gives me 31 tens, and I have five ones. Okay. Very good. Let's do a few subtraction problems. I have an interesting way to think about subtraction here. Let's start with something that's not so bad, like 120 minus 60. And this is really one where working from left to right helps a lot. And you get 60. And you really think, what's 12 minus 6? 12 tens minus 6 tens. All right. If you were doing it with borrowing, then you have to do things like this. And I hope you don't have to do that. You just have to practice so that you don't need to do that. If I were working from right to left, that's what you would have to do. Okay. So working from left to right with subtraction can be very helpful. It gets a little bit weird, and we'll talk about that. But that one's not so bad. 120 minus 60 is 60. Let's say 257 minus 70. Okay. Give you a moment for that. Try to go from left to right. So if I'm working from left to right, I'm thinking, what's 25 minus 7? And I get 18. 7 minus 0 is 7. Okay. All right, let's talk about, let's do one more that has a bigger number in it. So let's say 1,416 minus 114. And try to do it mentally. So your 1,302, 1 minus 0 is 1, 4 minus 1 is 3, 1 minus 1 is 0, 6 minus 4 is 2. And when you're looking at those, I hope that you start, and we've talked about this in previous lessons, whether you needed to borrow or not. Okay. When you look at a subtraction problem, it's always helpful to first just take a moment and look at it and try to figure out if you need to borrow. And this one, we didn't have to do any borrowing at all. And when we have subtraction problems where we don't have to borrow, going from left to right actually is not so bad. Okay, so we don't have to worry about any type of borrowing. The question is, what happens if you have a problem and you have to borrow? Okay. There's a lot of ways to look at this. We've talked about some of those ways in previous lessons. But remember, the whole focus of this lesson is working from left to right. Now, my first question to you is, when you look at that, do you have to borrow, and how do you know? Okay, and this one's not so bad because it's just a 2-digit by 2-digit. But I'm looking at this and saying, okay, I'm not going to be able to take 8 from 7 without borrowing. Okay. So the way this works mentally is, again, we're starting from the left. What's 4 minus 2? And because I have to borrow, I actually go subtract 1 from that. So 4 minus 2 is 2, and because I have to borrow, I subtract 1 more from 2, and I know I have a 1 there. Okay. Then I just ask what's 17 minus 8, which is 9. Okay. Now, I didn't do anything different than the way you would do it if you were borrowing. I just did it in a different direction. If we were borrowing, I would make that 4 a 3. I would borrow a 10. 17 minus 8 is 9. And 3 minus 2 is 1. I just did it in reverse. 4 minus 2 is 2. But because I have to borrow, I make it 1 less than that. And then I figure out 17 minus 8. Let's do one more. Let's do 116 minus 28. And try to do it the same way and try to do it mentally. And this one I threw a little curveball in there for you, but that's okay. So remember, we're thinking, okay, I'm looking at that, and that's telling me I'm going to need to borrow. I could look at this too, and that's where my curveball is. But if that tells me I have to borrow, then I want to figure out 11 minus 2 and subtract 1 more from that. So 11 minus 2 is 9. 1 fewer than that is 8. Then I just need to know what 16 minus 8 is, which is 8. Now, we've talked about in previous lessons that you could think of this as 116 minus 26. Maybe some of you do. And then you get 90, and then you have to ask yourself, did I subtract too much or not enough? I didn't subtract enough, so I still need to subtract 2 more, which is 88. And when you start looking at these problems in all those different ways, and that's why we keep talking about all these different strategies, it's because you are going to find the ones that make the most sense to you. And it might not be the ones we're talking about today, and that's okay. But if you're going to, people that are really awesome with mental math, they quite often will do math left to right. It doesn't matter if it's addition, subtraction, multiplication, and certainly division. So we'll keep working at it and practicing. But there's so much to be learned, it's important to learn as much as you possibly can. Okay, now let's talk about one last thing. Sometimes what makes math hard is that you'll learn a bunch of stuff and then all of a sudden it changes. So you'll learn addition, subtraction, multiplication, and you'll do it from right to left. You'll start at your ones most of the time and you'll work your way to the left. And then you learn division. In division, you actually start working from left to right, like we've been talking about today. And that's weird. Sometimes that makes things hard. It's like, well, why do I work from left to right when I'm dividing, and I work from right to left every other time? And you absolutely could work from right to left when you divide. It's not very efficient. It's not as simple, and it's a lot to keep track of. And when you work from left to right when you divide, because you're taking a number and you're breaking it down. So it makes sense that you start with the largest place value and you work your way to the smallest. And I'm just showing you this because it's something interesting that people don't think that they can do, but you can. I can divide from right to left. So the question is, how many times instead does 6 divide into 6? Okay, that's once. And I can subtract in the same way that I normally do. Okay. I have 150. Now the question is, how many times does 6 divide into 0? Well, 0. So then I'd look at my next place value to the left. How many times does 6 divide into 50? 8 times. This is where it gets weird because I actually have to keep track of everything in a little bit of a different way. We'll erase some of that stuff. 6 times 8 is 48. So I'm going to subtract 48. I get 102. Now if I'm working from right to left, how many times does 6 divide into 2? None. How many times does 6 divide into 0, 2? None. How many times does 6 divide into 102? 17. Just 17 times 6 is 102. I subtract 102. I get no remainder. And then all I have to do is add those up. 1 plus 8 plus 17 is 26. 156 divided by 6 is 26. And why would you ever want to do that? You really don't, because it's long and complicated, but it proves that you can actually divide the opposite way that you normally do. So it's something kind of fun to think about, but I wouldn't suggest it too much. With all of that said, I am going to end the lesson for today. I thank you so much for joining me on a Friday. I hope you have an awesome weekend. I hope you check out Mathnasium if you're not a Mathnasium student. If you're a parent, we can help your kids so much by putting together an awesome plan and helping them with their homework. And I think we can do a lot of really great things. And I hope you continue to join us for the Schoolhouse. We are on Schoolhouse now because of school being back in session Monday, Wednesday, and Friday at 11 a.m. Pacific. So we will be back on Monday, and we will see you next week. Thank you so much. Stay safe. Bye now.
It's afternoons that seem to be the most hectic for us, so it was much more convenient when we found Mathnasium at home.
All right, so how do we do half of 5? I think one of the best things about at home is that it really feels like you're almost at home with the student in their house teaching them.
I'm in my comfort zone.
You can just ask for help and the instructor will come right to you.
With Mathnasium at home, I know that they're getting the help that they need.
Awesome, great job.
Mathnasium, changing lives through math.